Multimeters Explained. Number 1. An Introduction. This program introduces you to the two types of multimeters used today. Explains the functions of the basic controls found on each multimeter that you need to understand for setup and operation. Compares the characteristics and applications of both multimeters. And shows the safety and maintenance procedures that you should follow when using them.
Multimeters are used to test and troubleshoot electronic circuits. Here, a technician is using a multimeter to measure resistance. Measuring current, voltage, and resistance, or checking for broken connections, are just a few examples of how a technician may use a multimeter. There are two types of multimeters, analog and digital. They both have the same basic features and controls. Both multimeters display information on a meter face. Analog and digital multimeters also have control switches for the selection of the measurement scale and range. Both multimeters provide recessed jacks for test leads which connect them to the circuit.
Let's take a look at the basic setup procedures for the analog multimeter. First, locate the function switch. You will see the following positions: off transit, positive DC or direct current, negative DC, and AC or alternating current. Let's set up the multimeter for resistance measurements by selecting the positive DC setting. Next, select the measurement range on the range switch. Here you will find 5 voltage positions: 500V or volts through 2.5 volts, 4 current measurements, 500 mA or milliamps through 1 milliamp, and 3 positions for resistance measurements, R or resistance times 1 through R times 10,000. Turn the range switch to the resistance setting that is closest to the value of the component being measured. The next step is to connect the multimeter to the circuit by using test leads. Each test lead consists of a probe, a connecting wire, and an elbow prod. Attachments are available that can be placed on the end of the probe to aid in the connection to various circuits. These attachments are spring-loaded hook tips and alligator clips. For resistance measurements, plug the black test lead into the common or negative jack and the red test lead into the positive jack. The next step is to use the 0 ohms control to adjust the meter scale for an accurate reading. This must be done to allow for fluctuations in the battery power level. First, connect the ends of the test leads together. Then, turn the 0 ohms control to align the needle on the meter face with the 0 at the right end of the top scale. Once you have zeroed the needle, disconnect the test leads. This is all that is required to set up an analog multimeter for resistance measurements. The setup procedures for the other functions follow a similar format.
Now, let's set up a digital multimeter to perform resistance measurements. The rotary switch on this digital multimeter combines many of the settings of the function and range switches used on the analog multimeter. This switch uses symbols called icons to represent the various functions. These are the icons found on the digital multimeter. The letter V, followed by a sine wave, represents volts AC, and when followed by a solid line over a dashed line, it stands for volts DC. The letters MV, followed by the solid and dashed lines, are for millivolts DC. The Greek letter omega represents ohms, which is the unit of measure for resistance. The diode symbol, followed by the curved lines, represents the continuity test that includes an audio tone. Lastly, the letter A, followed by a sine wave, represents amps AC, and when followed by the solid and dashed line, it stands for amps DC. Select the ohm symbol to do resistance measurements. You will notice that the multimeter will perform a brief self-test. Since the probes aren't connected yet, the resistance across the inputs is beyond the meter's range. Therefore, the meter will display the letters OL, which stands for overload. Choosing the range mode is the next step. This digital multimeter has two range modes, auto range and range hold. Auto range is selected whenever the rotary switch is moved from the off position. In auto range, the multimeter automatically chooses the best range. Here, the multimeter selected a multiplier of 1 meg, indicated by the letter M. Range hold allows you to manually select the range. To activate this feature, press the range button located in the middle of the rotary switch. This symbol will appear to confirm that you are in the range hold mode. The range button controls the location of the decimal point on the display. Each time you press this button, it moves the decimal point one place to the right. Holding the range button down for 1 second returns you to the auto range mode. This is confirmed by the absence of the range hold symbol. Next, you'll need to plug in the test leads. Connect the red test lead to the recessed jack labeled with the ohm symbol. Then, connect the black test lead to the jack labeled COM. You'll remember that when using the analog multimeter, the next step in the setup procedure was to adjust the 0 ohms control. However, the digital multimeter performs this task automatically by displaying a reading close to 0.
Although you've just completed the basic setup procedures, let's take a moment to look at an important feature of the digital multimeter called touch hold. This feature simplifies the job of taking measurements. To activate touch hold, first turn the rotary switch to the off position. Then, while holding the range button down, turn the rotary switch to the desired function using your thumb. When touch hold is activated, the same symbol used for range hold will appear in the display. In the touch hold mode, the multimeter captures the reading on the display when the test leads make contact with the circuit. You can then lift the test leads away from the circuit, and the reading will remain. Turning the rotary switch back to the off position deactivates touch hold. This is all that's required to set up a digital multimeter to do resistance measurements.
Now let's compare the characteristics and applications of analog and digital multimeters, starting with the displays. First, the analog meter conveys a sense of magnitude when displaying a reading. In other words, you can see where the needle is in relation to the two ends of the scale. The digital display alone does not give a sense of magnitude. To compensate, this multimeter has an analog scale along the bottom of the digital display that simulates the magnitude of the input.
Another difference is that there is a larger margin for error when using the analog type. An error can be made by choosing the wrong scale to read, or by viewing the meter face at an angle. The digital display allows less room for error by showing the exact value without your having to interpret a scale.
Analog multimeters are sensitive to vibration and are affected by the angle at which they're held. For this reason, the analog type is popular in the shop where it can be placed on a steady, level surface.
The digital type is not affected by vibration or the angle at which it's held. Therefore, the digital multimeter is popular in field service applications. In addition, the digital type sounds a tone when doing continuity checks, indicating a common connection. This allows the technician to work faster because there's no need to look at the multimeter.
The last difference to consider is price. The analog multimeter is less expensive than the digital type. As you can see by these comparisons, each multimeter has advantages and disadvantages.
There are important safety procedures to keep in mind whenever using an analog or digital multimeter. In general, use caution when measuring voltages in excess of 42 volts DC or 25 volts AC. These voltages represent a shock hazard. Always inspect the test leads. These leads have damaged insulation and need to be replaced. When using the probe without the optional attachments, keep your fingers behind the guard. Whenever possible, use the hook tips or alligator clips, especially when working with small parts. In addition to the shock hazard, having your fingers in contact with the circuit can change the values measured. When taking measurements, touch only one contact at a time. Touching more than one contact at the same time will often short out the circuit, causing damage to the components. If you are in doubt as to which range to select when doing voltage and current measurements, you can protect the multimeter by selecting the highest range. If the value being measured is within a lower range, continue to set the switch to the next lowest range until you find the one that provides the most accurate reading.
Multimeters are simple to maintain. Let's look at the maintenance procedures starting with battery and fuse replacement for the analog multimeter. It's necessary to replace the batteries when the needle on the meter face cannot be adjusted to 0 with the 0 ohms control. To replace the batteries, turn the multimeter over and loosen the screw on the cover located on the back. Then, remove the cover. Inside this compartment, you will see two batteries, a 1.5-volt size D battery and a 9-volt battery. The 1.5-volt battery can be gently lifted out of its holder and replaced. Be sure to observe polarity. To replace the 9-volt battery, gently slide it out of the compartment and remove it from the connector. Then, connect the replacement battery and slide it back into the compartment. The next maintenance item is fuse replacement. The fuses are secured in the battery compartment under this metal plate. To replace a fuse, rotate the plate and remove either of the two fuses. Always replace a fuse with one of the exact same value. When finished, replace the cover and gently tighten the screw. Lastly, the needle on the meter face will occasionally need to be adjusted to align with 0. To do this, be sure that the function switch is set to off. Then, turn the screw at the base of the needle until it is aligned with the 0.
Now, let's look at the maintenance procedures for a digital multimeter. As you've learned, every time you turn the digital multimeter on, it automatically performs a self-test. During this test, all of the display segments appear on the digital display. Now that you know that the display is functioning properly, look for this symbol in the upper left corner of the display. This is the low battery indicator. It's a good idea to change the battery as soon as this indicator appears. Now let's take a look at the battery replacement procedures. After removing the protective cover and the 4 screws on the back, gently lift off the front cover. Lift this end of the battery upward and remove it from the connector. Then replace the battery with a new one. Fuse replacement is a simple operation. To begin, locate the fuse. And lift one end first, then remove it. Do not lift the fuse straight out. Next, replace the fuse with one of the exact same value. With the new fuse in place, reassemble the multimeter.
The last maintenance item for both the analog and digital multimeters is cleaning. To clean either multimeter, use a damp cloth with mild soap. Be sure that liquids do not enter the case. This completes the introduction to analog and digital multimeters. In program number 2, you will learn how to measure resistance and check for continuity.